All right, now we're on the 2015 question number 5, which again you'll see is a very similar question. It deals with derivatives and integrals with graphs. Now, in this case, you're given the graph of f prime. There's a lot of information down here, so let's just go through it to make sure we're okay. The figure above shows the graph of f prime, the derivative of a twice differentiable function f. Now, all that twice differentiable really is going to mean is you don't have to worry about there being anything crazy on the graph. You can take derivatives and not have to worry about it. Okay, it's really just a safeguard saying don't worry about anything crazy happening. From the intervals -3 to 4. That's all we're looking at. That's all we can tell. The graph of f prime has a horizontal tangent. So remember, horizontal tangent just means that it has a slope of 0 at these three values, at -1, 1, and 3. All right? The areas of the regions bounded by the graphs of the x-axis, and we're going to write those in. I'll write those areas in. So the areas between -2 and 1 are 9, I'm sorry. Now I'm going to put -9 because it's kind of below the axis, so we think of it as a negative. And between 1 and 4 is 12. So remember, 9 is all of this, and 12 is all of this. You know what? I'm going to change my mind a bit. I'm not going to put negatives because we're just going to look at it on a case-by-case basis. So that area is 9, all of this, and this area is 12. All right. So, question 1. Find all the x-coordinates at which f has a relative max or min. Well, how do you find if f has a relative max or min? Well, you look at its derivative. So it has a max or min when f prime of x equals 0 or doesn't exist. And again, we have to worry about not existing in this particular example. Where does x prime of x equal 0? Well, it equals 0 at -2, at 1, and at 4. Okay. Now we test our points. Now 4 isn't, I probably don't have to do this. 4 is kind of our end point. It stops at 4. So boom, it just stops right there at 4. We don't know what happens on the other side of 4. So by default, 4 is not going to be a maximum or a minimum. But -2 and 1. So we test our derivative. Now there's no points to test. We just look at it. We know there's nothing past 4. Between 1 and 4, f prime is negative because it's under the axis. Okay. Between -2 and 1, f prime is under the axis, so its values are negative. And between -3 and -2, they're positive. So that means 1 is not a max or a min, okay? Because it's going down, it flattens out at 1 and goes down. And at 4, we don't know what happens, so we can't say. The only thing we have is we have a maximum at -2, because it goes up and it comes down. So f of -2 is a maximum. Now, it's going to ask you to give a reason. Unfortunately, the table alone is not a reason enough. You have to explain what this table says. So f prime of 2 is a maximum. You can say it a bunch of different ways, but I like to say it this way because f prime of -2, no, I shouldn't say it that way. We'll just say f prime of x. It changes from positive to negative at x equals -2. So there's your reason for it. There's your justification for why it's a maximum. Okay? All right, this one. What open intervals is the graph both concave down and decreasing? Now we had a similar problem in the 2014 version. So f is concave down when f double prime, the second derivative, is negative. Okay. F is decreasing when its derivative is negative. All right. So make sure we understand that. Concave down is second derivative. So concave down happens when f double prime is negative. Okay? F is decreasing. That's a first derivative. First derivative says increasing or decreasing. So if you want decreasing, we want to know when f prime is negative. So let's look on the graph and see if we can find these values out. So in yellow, let's put yellow highlighter. When is f double prime negative? Okay, now remember, we're looking at the graph of f prime. So be very, very careful. If we're looking at the graph of f prime, f double prime is its derivative. And its derivative is negative when the slopes are negative. So from here to here, its slopes are negative. It's decreasing. It's increasing. And then from 1 to 3, the first derivative has a negative slope. That's the thing you got to be really careful of and make sure you understand. So you're looking at the graph of f prime. Now that makes this part easier. Where is f prime negative? Well, f prime is negative anywhere it's under the axis. It actually makes that one kind of easy, because f prime is negative under there. Okay? So where are they both true? And I kind of overlapped them a little bit. Whoops, I didn't mean to move that one. I moved this one a little bit. Okay, so where are they both true? They're both true from -2 to -1. So f is concave down and decreasing on. So -2 to -1 and 1 to 3. Okay. So again, you know how to do all these. You've seen them, you've done them, but they're asking these things in a slightly different way. All right, let's go to C. Find all the x-coordinates of the points of inflection. Now remember, points of inflection are a second derivative. When is a second derivative equal to 0? Okay. Now, if we are given f prime, don't forget that f double prime is the slopes of f prime. All right. So I want to know where the slopes equal 0. Well, they told you. -1, 1, and 3. It was given to you all right here. So -1, 1, and 3. Then I'm testing. -1, 1, and 3. So again, we're looking at f double prime, the slopes of this graph. So before -1, all the slopes are decreasing, or all the slopes are negative. I'm sorry, the function is decreasing. All the slopes are negative. Between -1 and 1, the slopes are positive. Between 1 and 3, the slopes are negative. And from 3 up to 4, the slopes are positive. So it looks like we got 1, 2, we got 3 points of inflection. So we have points of inflection at -1, 1, and 3. Okay. Now, why? Okay, so you can just say that f double prime changes sign. Oh, not sing. That's for later. After you're done with all this stuff, you can sing praises of joy, because f double prime changes sign at those values. All right. Last one. Hopefully you can see a little rhythm to this stuff. You can see how things go along. All right, now here's an interesting question. Given that f of 1 is 3, write an expression for f of x that involves an integral. We're going to find f of 4 and f of negative 2. Now remember, we're given the slope. We're given f prime. So to find f, we go that backward step. From f to f prime is a derivative. So from f prime to f is an antiderivative. So in general, f is going to be the antiderivative of f prime. Hopefully that makes sense because the integral of a derivative is the original function. Now if you look at f of 4 specifically, we are going to go to 4. Now the question is, where do we start? The area of what? All of it? Nah, our clue is right here. We're starting at 1, and here's the reason why. What is the value of f at 1? Well, it's 3. I already know what it's going to be up to 1. Up to 1, the answer is 3. Now I'm just going to tack on the extra from 1 to 4. Okay? So I know what it is up to 3, and I'm adding on the extra from 1 to 4. That's what this means. Now we were actually told what this value is. From 1 to 4, the area is 12. But the 12 is below the axis, and we're traveling this direction. We're traveling positive, right? So it's below the axis, so it's negative 12. So that equals negative 9. F of 4 is negative 9. Now it gets a little bit more complicated with negative 2. Because we're still starting at 1. We're starting at 1 and we're going to negative 2. Probably should put prime to be safe. And we start adding that 3 to it because 3 is our starting value. But now we're going this way. So there's 2 ways to think about it. The area from negative 2 to 1 is 9. But since 9 is below the axis, it's negative. But since we're traveling backward, it's another negative. We're going to take the opposite of that. So we're actually going to take 9 and add 3 to it. And we get 12. So f of negative 2 actually equals 12. Now that's one way to think about it. If we're traveling from a certain spot and we're traveling the opposite direction that we're used to, so the negative direction, it changes everything. So instead of this being negative 9, because it's below the axis, it becomes a positive 9. The other way to think about it is, well, we'll put it this way here. Maybe this as an alternate way to explain why this is true. What we know is that we usually have the lower number here, don't we? So remember this little identity? If we reverse these and go from negative 2 to 1, I reverse the sign. Okay, really the whole sense is, was going to be the direction we're going. If it's backwards, it's negative. And if you think about that, if you understand that these two are opposites, well, what is the area between negative 2 and 1? Well, it's negative 9 because it's below the axis. So what's the opposite of negative 9? Positive 9. So 2 different ways to think about that. Okay. And that's question number 5 from the 2015 test, which is very similar to the one we did before. I'll be posting one more video about the 2016 question, which again you'll find is very similar. And I have sent you a file that has 2014 through 2019, all similar questions. So I want you to go over those as best you can in our live sessions on Tuesday, and on Thursday most likely we'll go over any questions you have on that. All right, I'll see you later.